Hello students, welcome to the lecture on management of data resource, and after this lecture we will be able to learn the following objectives. Understand concept of data resources, learn the methods of data collection and understand the database trends. First of all, let me explain what management of resources of data is. The word data is defined in Webster's 11th collegiate dictionary as factual information, as measurements or statistics used as a basic for reasoning, discussion or calculation. Data is stored and managed according to a principal structure that administrators can view and configure. The data is stored in database tables and records. Various tools exist to manage this data. Data import and export simplifies managing large sets of data. Field normalization makes records more readable and prevents duplication of data. Scripting support allows for advanced customization and automation of data management.
About 360's enterprise software. It's PDM-like software with the capability of EPDM inside 360. So it's data management and resource management as well. So in that software, what's cool is we can search anything. We can search using Google, for instance, looking up for a customer, supplier, or even technical information. We can also search throughout 360, including EPDM. So if I'm searching part like NREL, I have results with previews and information regarding that part. Also, I have a list for my result. So if I double click on that file, it will give me the file inside EPDM. I can right click on it and go into preview mode. And the preview mode is different from what we get with EPDM, but it's a cool tool to use as well. So we can add some measurement like this one right here. And from there, I can go into the redlining tool. So if I wanted to add some redlining, I just select the screen I want to redline. And from there, I can add arrows or text or even shapes, like this one, to make sure that I get my point across. So I save this redlining on the part. So what it does is it adds an object to a file, like this one right here. I'm going to zoom on it so you can see I have my redlining on that part. We can take that part and add it to a favorite bar or a link like this one right here. Now that this is done, we can also have a dashboard. The dashboard is somewhere where we can put stuff that we work on a lot. We can add widget or apps, like a clock widget, like this one. We can also add bookmarks if we want. Bookmarks will act like a favorite, just like the toolbar. So I'm adding a bookmark right here. I'm going to take this part and just drag it in like this. And if I'm working on some project, I can go into the project management tool and just drag and drop the project that I'm working on, like this thing right here. There we go. So let's go inside the project management tool. If I open my project, we have a preview or an overview. Like this thing right here. I'm going to make some room like this. We go into the Gantt, and from there, to show you that it's a project management tool, I'm going to expand all the tags that I have. And why not use also the critical path? So this is something that we use a lot. So this is my critical path. I'm going to click on this link button right here, and from there I can add files to a task. So let's take this SOLIDWORKS part, add it to this task. And from there, I have everything I can do from the right-click menu inside my part.
Let us move on to the concept of data. Data processing. Data processing is a data collection, storage, retrieval, processing, transformation, and transmission. Data is facts, concepts, or instruction of a form of expression, can be manual or automated device for processing. The form of digital data, text, graphic or sounds. Data are explained and after giving a certain sense, they become information. A database management system provides the ability for many different users to share data and process resources. Users, however, may wish to see data differently from how they are stored, and they do not want to know all the technical details of physical storage. After all, a business user is primarily interested in using the information, not in how it is stored. The logical view or user view of a database program represents data in a format that is meaningful to a user and to the software programs that process those data. That is, the logical view tells the user in user terms what is in the database. Strength of DBMS is that while there is only one physical view of the data, there can be an endless number of different logical views. This feature allows the user to see database information in a more business-related way rather than from a technical processing viewpoint. Thus, the logical view refers to the way user views data, and the physical view to the way the data are physically stored and processed. As data volumes continue to grow exponentially, advanced storage management solutions have become increasingly important. Not only is capacity management necessity, but so too is flexible data access. While network attached storage (NAS) and storage area network (SANS) are clear options for expanding LAN-based storage architectures, IT managers and integrators should be aware that the traditional storage management approach of linking data to physical resources may not effectively support and protect these new storage infrastructures. Many LAN-based storage management products can adequately protect devices, albeit a limited number in a single architecture, LAN, NAS or SAN, but few enterprises rely on a single architecture for all their storage requirements. Far more typical do environments that encompasses multiple storage architectures comprise multiple devices. In these environments, traditional storage management software faces a challenge with a separate physical view of each architecture and each device within that architecture. Centralized, unified management over the entire storage environment is difficult, if not impossible. While this may be an unacceptable limitation for smaller enterprises, it is not likely to be so for larger ones. The added costs and resources required to manage multiple storage environments do not make economic sense in such complex environments where data access optimization is critical. Equally important, this data movement is the key enabling technology for serverless backup, but without the ability to assemble data affected by block-level movement into a logical presentation, it is difficult. The key characteristic of the data that is stored by a directory service correspond to size and latency. Active Directory should store objects that are not so large that they hamper replication and not so unstable that they change before an update replicates to all replicas in the forest. Therefore, large unstructured data sets and data values that change frequently are not appropriate for storage in Active Directory. Active Directory is appropriate for the storage of data that has the following characteristic. The data has well-defined object attributes and semantics. The data has a useful life that is at least 2 times the maximum replication latency for the forest. The data has a useful life that is at least 2 times the maximum replication latency for the forest, to include replication of data that is marked to replicate to the global catalog. In general, if data can become outdated before the completion of a replication cycle or shortly thereafter, it should not be stored in Active Directory. Clients should be able to tolerate the inability to update data for at least as long as it takes for the data to be replicated throughout the domain. The data per attribute value is not so large that it affects performance. An attribute value is replicated as a single block of data. Therefore, an attribute that is X megabyte in size requires an equivalent amount of buffer space in the sending and in the receiving domain controllers. If the amount of required buffer space is large, the performance of the domain controller can be adversely affected. Data can be described as the backbone of any Six Sigma project. This is because the whole idea of Six Sigma and operation is to use statistic to manage operation in the factory workshop. Hence, for a Six Sigma team to understand the types of data and when and how to use them is of vital importance. Here are the types of data that are used for statistical analysis. Continuous data. Continuous data is of the type that must be measured as against the type that we can count. Consider, for example, length of an object as a data type. Length of an object can be between 1 foot and 2 feet. It can be 1.5 feet. It can be even be 1.54 or 1.546 feet, depending upon the number of decimals and the degree of precision that have been decided in the data collection plan. Discrete data. Discrete data is the data that needs to be counted as opposed to being measured. Here, the values fall in one of the categories. Binary. The data in such cases needs to be entered in one of the two categories like true or false, applicable to Six Sigma analysis or not applicable to Six Sigma analysis. Ordered categories. The data in these cases needs to be entered in one of the multiple categories that are ranked. Unordered categories. The data in these cases is entered in one of the multiple categories that need not be ranked. Count. This is simple counting of data without any categorization involved. A register is a depository of information on fishing vessels, companies' gear, licenses, or individual fishers. Registers are implemented when there is a need for accurate knowledge of the size and type of the fishing fleet and for closer monitoring of fishing activities to ensure compliance with fishery regulations. In most countries, vessels, especially commercial fishing vessels and chartered or contract fishing vessels, are registered with the fisheries authorities. Data on vessel type, size, gear type, country of origin, fish holding capacity, number of fishes and engine horsepower should be made available for the registry. Companies dealing with fisheries agencies are registered for various purposes. These companies may not only include fishing companies, but also other type of companies involved in processing and marketing fishery products. A registry must not only capture new records but be able to indicate that a particular record is inactive or record changes in operation. Registry data also contain criteria for the classification of fishing units into strata. These classifications are usually based on assumption and a prior knowledge regarding differences on catch rates, species composition, and species selectivity. Small-scale and subsistence fisheries involving large numbers of fishing units are often not part of a register system, or if registered, are not easily traced so as to allow validation or updating. In contrast with interviews where an enumerator poses questions directly, questionnaires refer to forms filled in by respondents alone. Questionnaires can be handed out or sent by mail and later collected or returned by stamped address enveloped. A questionnaire requires respondents to fill out the form themselves and so requires a high level of literacy. Where multiple languages are common, questionnaires should be prepared using the major languages of the target group. Special care needs to be taken in these cases to ensure accurate translation. In interviews, information is obtained through inquiry and recorded by enumerators. Structured interviews are performed by using survey forms, whereas open interviews are notes taken while talking with respondents. The notes are subsequently structured, interpreted for further analysis. Open-ended interviews, which need to be interpreted and analyzed even during the interview, have to be carried out by well-trained observers and or enumerators. As in preparing a questionnaire, it is important to pilot test forms designed for the interviews. The best attempt to clarify and focus by the designer cannot anticipate all possible respondents' interpretation. Open-ended interviews cover a variety of data gathering activities, including a number of social science research methods. Panel surveys involve the random selection of a small number of representative individuals from a group who agree to be available over an extended period, often 1 to 3 years. During that period, they serve as a stratified random sample of people from whom data can be elicited on a variety of topics. Generally, structured interviews are conducted with a well-designed form already established. Forms are filled in by researchers instead of respondents, and in that it differs from questionnaires. While this approach is more expensive, more complicated questions can be asked and data can be validated as it is collected, improving data quality. Interviews can be undertaken with a variety of data sources, fishes to consumers, and through alternative media such as by telephone or in person. Structured interviews form the basic for much of the data collection in small-scale fisheries. Observers can make direct measurements on the fishing vessels at landing sites, processing plants, or in markets. The variables that enumerates can collect include catch, landing and discard, effort vessels, gears, operations, environmental variables, example sea state, temperature, biological variables, example length, weight and age, the values and quantities of landings and sales. Inspectors are a kind of enumerator involved in law enforcement and surveillance for fishing regulations, sanitary inspections, labor control, etc. They may work at sea, on surveillance vessel, at landing sites on shore, at processing factories, and at markets. Nevertheless, many variables collected by the inspectors are very useful and include landings, operational information, effort, landing price, processing procedure, and values of product to the market and processor. Inspectors are also useful in collecting employment data. Inspectors may play an important role in verification. In many cases, reports can be physically checked with observation. The advantage of using reports is that data are compiled by agents other than fisheries staff and sometimes can be made available in pre-processed, computerized format directly from the company's records, thereby reducing administration costs. Confidentiality of information such as fishing grounds and catch rates should be part of the agreement for data submission, and statistical outputs of the survey should not contain information related to individual fishing vessels or companies. Data mining, also known as knowledge discovery, refers to computer-assisted tools and techniques for shifting through and analyzing these vast data stores in order. The monumental task of finding hidden gold depends heavily upon the power of computers. Marketers can effectively target the wants and needs of specific consumer groups by analyzing data about customer preferences and buying patterns. Hospitals use data mining to identify groups of people whose health care costs are likely to increase in the near future so that preventative steps can be taken. A data warehouse is a relational database that is designed for query and analysis rather than for transaction processing. It usually contains historical data derived from transaction data, but it can include data from other sources. It separates analysis workload from transaction workload and enables an organization to consolidate data from several sources. Database designing is arguably the most important part of a project. Unfortunately, it cannot be taught. The only way to learn how to design is by design databases. There are some other concepts that you need to keep in mind when designing the databases.
Okay, let's start with normalization. Normalization is the process of organizing data in a database. This includes creating tables and establishing relationships between those tables according to rules designed both to protect the data and to make the database more flexible by eliminating two factors, redundancy and inconsistent dependency. Redundant data wastes disk space and creates maintenance problems. If data that exists in more than one place must be changed, the data must be changed in exactly the same way in all locations. A customer's address change is much easier to implement if that data is stored only in the customer table and nowhere else in the database. There are a few rules for database normalization. Each rule is called a normal form. First normal form, also called atomic. In first normal form, it dictates that for every row by column position in a given table, there exists only one value, not an array of lists of values. An example would be right here where I have city, state, and zip. If lists of values are stored in a single column, there is no simple way to manipulate those values. Retrieval of data becomes much more laborious and difficult to generalize. Those should actually broke out in the table. One column for city, one column for state, one column for zip. Second normal form, no repeating groups. Again, under Training Center space bad, which is not how you want to name things, we'll get that later. You say have phone, phone 2, and phone 3. If you're going to have repeating groups, you should break those off into a separate table, maybe just a table called phone. That is second normal form. Third normal form, no redundancies. Everything should depend on the key as it is. So also in this bad table I created just for an example, you'll see we also have certifications and classes. That is redundant data because we have a class table and a certification table. Redundant data means that if I was to change the certification and the class, I'd also have to go into this table and change it also. Another obvious example of a dependency is a calculation column. For example, now that we have the cost for classes and the cost for tests, and I wanted to find what the total that a consultant had spent on a yearly record for those two classes, and I entered a total column here, it would have to write out the total every time I changed the costs, and it would be redundant. You should actually save that for a query. Next, let's discuss indexes. An index is a separate file that is sorted and contains only the fields you're interested in sorting on. If you create an index on, let's say, certification name, like I have, a SQL database can find the corresponding record very quickly. Indexes work in a very similar way to an index in a book. Imagine paging through a technical book, or more often, a scrambled pile of notes looking for the topic on optimizing a SQL database. An index saves you an immense amount of time. Other indexes that I have put is under consultant name, consultant first name and last name. Another rule is you should not have more than 3 on a table, because for each time that you write information to that table, if you had 4 indexes on top of just the information on that table, you'd actually have to write 5 times, and that could start to slow the database down after a while. Let's now go to primary and foreign keys. There are 2 types of keys, primary and foreign. Both of them can be created when you create the table or after the fact, as long as you don't violate any of the rules that you placed in effect. The concept of a primary key is pretty simple. It's a value or a set of values that makes a particular row or record in a table unique. While working in Visio, everything that's bold above the first line here with the PK next to it is my primary key. An interjoining table like Class Center here that joins Class and Training Center uses the primary ID from each table together to form the primary key for Class Center. This also breaks the many-to-many relationship, which you do not want to have either for redundant reasons. The primary key of a table has to be unique. A primary key can be made up of several columns, because sometimes one column alone does not make a row unique, like Class Center. This type of primary key is also called a composite key because it's made up of several columns. While primary key enforces entity integrity, as I explained earlier, Foreign keys are used to enforce referential integrity. Referential integrity guarantees that references from one table to another are enforced by the database and not just in queries. From here, it could be also enforced by constraints or triggers. Another thing that I need to go over with you today is called data types. In a SQL Server, each column has its own data type. It is an attribute that specifies the type of data that an object can hold. Usually it is an integer or a character. It could be monetary, date, time, binary, and there's a lot more, but we're not going to go into that depth right now. When two expressions that have different data types or length are combined by an operator, the characteristics of those results can be determined, but I'd have to go way too far into depth for an intro to database discussion. Basically, if cost here was an integer and cost here was a character, that would be like trying to add a plus 1, which would equal 2 probably, because it's only one character. But what you want to try to do is keep it like I have. I use both my cost fields as decimal. Visio automatically makes it 10,2, which would be 10 decimals to the left, 2 decimals to the right, which can be used for monetary value also. 10 is like $1 million, and I don't think any class or test is going to cost that much, but I cannot change the 10. This pretty much sums up data types, indexes, normalization, and primary and foreign keys. Classes and specifications not dependent on address. That covers first, second, third, and form. Conventions for today is class. Lowercase is in uppercase. Class, no space, center. Both C's capitalized. This is referred to as camel case. Also in columns, same as the table names, are in lowercase, and the first character of each word is in uppercase. There are no spaces between words. Certification name. Capital C, certification, capital N, name, no space in between. Today I have shown an overview of relational database theory or normalization. I have tried to the best that I can to explain keys, data types, and index decisions. Oh well, I haven't really decided, I haven't told you why I've chosen to index name and first name, but usually because they're quicker to find. If you have a problem finding someone, you usually ask, well, what's your last name? And then when you pull up their last name, you might find that there's, my last name is Erickson, there's 4 Ericksons, so then you ask what the first name is, and you find out that there's only one Adam Erickson. You can go into depth if you were to actually ask for their social security number or birth date also. It does not create the only table I can actually use is transfer shows everything that you don't want to do. So I will be removing it before I finish this tutorial. Training Center Band also has improper naming conventions. The primary key is an address. Well, if the address is a building and there's 4 companies in the building, that doesn't make a good primary key. I have also decided to mess up all 3 normal forms inside one table. It'd be easier to just get rid of that table and not have it connect to anything. And that concludes my preview of database design.
The hierarchical data model is a way of organizing a database with multiple one-to-many relationships. The structure is based on the rule that one parent can have many children, but children are allowed only one parent. This database structure was one of the first used because it lends itself very well to linear type storage mediums, such as the data tapes that were used when databases were first created. It was originally created by IBM and was implemented mainly in their information management system, the precursor to the DBMS. The model allows easy addition and deletion of new information. Data at the top of the hierarchy is very fast to access. It was very easy to work with the model because it worked well with linear type data storage such as tapes. It relates well to anything that works through a one-to-many relationship. For example, there is a president with many managers below them, and those managers have many employees below them, but each employee has only one manager. This model has many issues that hold it back now that we require more sophisticated relationship. It requires data to be repetitively stored in many different entities. The database can be very slow when searching for information on the lower entities. We no longer use linear data storage mediums such as tapes, so the advantage is null. Searching for data requires the DBMS to run through the entire model from top to bottom until the required information is found, making queries very slow. Can only model one-to-many relationship, many-to-many relationship are not supported. The popularity of the network data model coincided with the popularity of the hierarchical data model. Some data were more naturally modeled with more than one parent per child, so the network model permitted the modeling of many-to-many relationship in data. The basic data modeling construct in the network model is a set construct. A set consists of an owner record type, a set name, and a member record type. Member record type can have that role in more than one set, hence the multi-parent concept is supported. An owner record type can also be a member or owner in another set. The data model is a simple network, and link and intersection record types called junction records by IDMS may exist as well as sets between them. RDBMS, Relational Database Management System, a database based on the relational model developed by E.F. Card. A relational database allows the definition of data structures, storage and retrieval operation and integrity constraint. In such a database, the data and relationship between them are organized in tables. A table is a collection of records, and each record in the table contains the same fields. The relational database model is based on the relational algebra. Properties of relation table. Values are atomic, each row is unique, column values are of the same kind, sequence of columns is insignificant, the sequence of rows is insignificant, and each column has a unique name. Object or Relational Database Management System (ORDBMS) add new object storage capabilities to the relational system at the core of modern information system. These new facilities integrate management of traditional fielded data, complex objects such as time series and geospatial data, and diverse binary media such as audio, video, images, and applets. Database designers can work with familiar tabular structures and data definition languages (DDLs) while assimilating new object management possibilities. Query and procedural languages and call interfaces in ORDBMS are familiar. SQL3, vendor procedural languages, and ODBC, JDBC, and proprietary call interfaces are all extensions of RDBMS languages and interfaces. Objects DBMS add database functionality to object programming languages. They bring much more than persistent storage of programming language objects. DBMS extend the semantics of the C++, Smalltalk, and Java object programming languages to provide full-featured database programming capability while retaining native language compatibility. A major benefit of this approach is the unification of the application and database development into a seamless data model and language environment. As a result, applications require less code, use more natural data modeling, and code bases are easier to maintain. A collection of programs that enables you to store, modify, and extract information from a database. The terms relational, network flat, and hierarchical all refer to the way a DBMS organizes information internally. There are many different types of DBMS, ranging from small systems that run on personal computers to huge systems that run on mainframes. Following are examples of database application: computerized library system, automated teller machines, flight reservation system, computerized part inventory system. From a technical standpoint, DBMS can differ widely. The terms relational, network, flat, and hierarchical all refer to the way a DBMS organizes information internally. The first step in the public procurement process is to identify requirements. All procurement requirements begin with the perception of a need. The need to cross a body of water could create a requirement to build a bridge, a ferry, or other transportation system. At the end of the requirement definition stage, a clear determination of the terms of reference, technical specification or statement of work, depending on the procurement category, should be possible, including an estimate of the budget and, most importantly, the procurement lead time. This requirement definition analysis is essential not only for new procurement requirements and project initiation and concept development, but also for requirements needed for maintaining existing operation. Now in the end, let us summarize what we have learned in this lecture. Data processing is the data collection, storage, retrieval, processing, transformation and transmission. A database management system provides the ability for many different users to share data and process resources. Logically viewing data provides a range of potential benefits to leverage existing and evolving storage architectures. A register is a depository of information on fishing vessels, companies, gear license, or individual fishers. Objective: Relational Database Management System (ORDBMS) adds new object storage capabilities to the relational system at the core of modern information systems.